Good evening, everyone. I'm Ganesh, and the topic for today is SDN programming languages. And let us begin with the introduction. So, software-defined networking is the um, emerging architecture that differentiates the network control and forwarding functions, enabling the network to be directly programmable. And when we talk about the infrastructure that lies beneath the software-defined network, um, there are many foundational parts for building a widely used SDN architecture that needs to be designed. So for that, there is a need of an organization. One such organization is the Open Networking Foundation, which is dedicated to uh, develop and standardize the uh, SDN. Um, Let us talk about how this particular organization has classified the standard network software defined network architecture. So, Open Networking Foundation has classified the architecture into three main layers. That is the data plane, control plane, and the application plane. So in the data plane, the network devices are managed by a remote and are differentiated with the control plane. The control plane observes and controls the whole network from a logically centralized point, offering functions such as access control, orchestration, and network virtualization. Uh, the application plane performs network functions such as routing, load balancing, and firewall. Let us talk about the. So this is the diagram which talks about the architecture and how these three layers, that is the data plane, control plane, application plane, are interfaced with each other. So if you can see between the data plane and the control plane, it is interfaced by the CDPI, that is the control data plane interface. And between control plane and application plane, it is interfaced by the NBI, that is the northbound interface. So how are these three layers linked? So looking at CDPI, that is the control data plane interface. So that is the interface between data plane and control plane. Um, it is also called as southbound interface, and it performs and controls all the forwarding operations. It has the capability of advertisement, statistic reporting, and event notification. One such example of CDPI is the OpenFlow. And when we talk about NBI, that is the northbound interface, that is the interface between control plane and application plane. So they typically provide abstract network views, enabling to express network behavior and requirements. So in the control plane, the control plane has the main component, that is the controller, which exposes and abstracts network functions and operations through the northbound interface. And when we talk about application plane, it is the highest level in the SDN architecture. So this plane is composed of one or more SDN applications. So the applications consist of application logic, um, or one or more NBI drivers. So these applications explicitly, directly, and programmatically communicate through their network requirements and desired network behavior to the SDN controller through the NBI. So when we talk about SDN programming is classified into three different levels. That is the low level programming, API based programming, domain specific programming. So in the low level programming, um, the networks are directly programmed through the CDPI. As we mentioned, the example of CDPI is the OpenFlow. So OpenFlow is it is the most used type of program that is used by CDPI. So the OpenFlow forces the programmers to manipulate bit patterns in packets and carefully manage the shared rule table space. Moreover, each network device must be programmed individually. That means like each particular switch or whatever the device that is in the that comes under for the low level programming, they should be configured individually and programmed individually. So these help in I mean, when it comes to errors and inconsistency detection, they should be handled manually. Um, and for low-level programming, they are programmed under general purpose general purpose language, that is C, Java, Python. So these are some of the examples of general purpose languages. So when we talk about API-based programming, APIs present the same problems as a low-level programming. So the APIs, they oblige programmers to reason manually in unstructured and ad hoc ways. So that is like with low-level dependencies among different parts of their code. So like for example, if the application that performs multiple tasks like routing, monitoring, access control, and server load balancing. So in most of these situations, they must ensure that packet processing rules are installed to perform the task, and they do not override uh, with one another. So with this, it will obviously be difficult for the programmer to write, test, and debug the program. And when we talk about domain-specific programming language, that is so domain-specific programming language is it is an expressive power focused on and usually restricted to a particular problem domain. So, like for example, uh, the SDN programming language have a compiler which is responsible for translating their high-level constructs to messages understandable by the controller API. And so the diagram here, so the diagram in this, sorry, not this one. Sorry, yeah, I just didn't explain this is the API based programming. This is domain specific language programming. And so if you look at this diagram, so this is, this shows the classification of the SDN programming languages. So that is like, it is classified under flow installation, policy definition, programming paradigm, and abstraction. So to be classified under these programming languages, they must be they must be considered under the feature-oriented analysis, which means like the primary focus of this method is to identify the prominent way or a distinctive feature on the specific domains. So the first one, if we So yeah, so when we talk about flow installation, yeah. So yeah. So before talking about the flow installation, let me give you an example how um, um, to like use how to implement dynamic applications by taking an example. So let us consider an example. So if the network access will be limited to devices based on maximum bandwidth usage. So here, if we consider PC1 and PC2 exchange up to 5 gigabyte of HTTP. So with the help of OpenFlow, the switches the I mean OpenFlow rules, the switches using controller APIs, it is necessary to implement the following steps. That is, the first one is it creates a flow table rules that is matching exclusive HTTP traffic between PC1 and PC2. Then the next step, it sends periodic statistic reports requests to the switches to collect the HTTP amount transmitted. Then the next one is it interpret the statistic replies and store them in a manner allowing to know every minute how much has been transmitted. That is the packets. Then finally they will test if the total transmitted is lower than 5 gigabyte. If so, then the continuing for so the I mean the it will continue to forward traffic between PC1 and PC2. Otherwise, it will drop the traffic until the total transmitted comes lower than 5 gigabyte. So yeah, as I told you about feature oriented domain analysis. So like for the table here, I mean the diagram here, it shows like how the programming languages are differentiated according to certain features. So like flow installation, policy definition, programming paradigm, and abstractions. So let us talk about the flow installations. So in flow installation, um, it is the way the languages install the rules on a particular device, like switches. So so the flow installation has can be installed. I mean, the rules can be installed um, on the switches either in two methods, that is the reactive approach and proactive approach. So in the reactive approach, so for example, if a packet arrives at a switch, then the lookup operation is performed in the flow table. And if there is no match between the arriving packet, the table creates if there is no match between the arriving packet and the flow table, the switch creates an open flow and sends the packet to the controller. Now the controller looks at its program logic and installs the necessary rules required to match the flow table. So that is the reactive. So it performs a reaction by looking at the uh, problem that it approaches. And in the proactive approach, it eliminates the latency induced by reaching out to the controller on each new flow. So if there is any new, like on each new uh, packets are transmitted, so the latency will be induced by reaching out to the controller. So the flow installation protocol reaches out to the controller, and the flow tables are generated beforehand. That is, it checks the traffic matches, and if that were not able to enter the switches. So by predefining all flows and actions in the switches flow table, the packet in will never occur. So that is another way um, of flow installation. So these are the two methods, that is reactive approach and proactive approach. The other one is policy definition. Policy definition is also known as an aggregation of policy rules. So, as the name itself says, that policy means like a rule which consists of a set of rules and set of actions according to the particular condition and where it is applicable to. So, these policies are triggered in two ways, that is static and dynamic. So, under static, obviously, so there are like fixed set of actions which are already predetermined uh, according to the parameters. And static is the most traditional method of firewalling. So firewalling is like filtering out unnecessary things in a network in a network. So static means like fixed set of actions that are predetermined according to the parameters. So like there are already set of actions that need to be taking place. So for firewalling, it will help the firewall to filter out whatever packets or certain things that need to be taken out with the help of static. When we speak about dynamic, uh, dynamic is enforced based on changing conditions of the network. So for like during congestion, packet loss, bandwidth usage, loss of network device, or maybe some external event. So based on the changing conditions, a dynamic policy will take place. And programming paradigm. So in programming paradigm, uh, that is it's a different way of building the structure and elements of the computer programs. And obviously, it consists of different styles, capabilities that are defined by their supported programming paradigms. So there are so the programming paradigm is classified into two types, that is imperative and declarative. Um, Under imperative, uh, it can be considered as a traditional computer programming model. This helps the programmer to specify the steps to solve a particular task. Um, so during computation, it is seen as a task. So it can be performed by processing unit that manipulates and modifies memory. So under declarative, one can specify what program must do. So like for example, if a particular function requires what kind of specific action is required, so that will be declaring. So that will be declared. And so I mean that also may not be known. Like they might say what needs to be done, but they won't say how to approach that method. Like how would you solve it? So one such example is the SQL, that is structured query language. So in SQL, we there are predefined tables and data. So with the help of that, we um, we can gather information through queries with the help of the database. And let's talk about abstractions. So in abstractions, there is consistency. So under consistency, it talks about the per packet flow, how many packets have been traversed, and what is its consistency. Was there any flow, I mean was there any packet loss? And that's what it talks about, I mean for the whole entire system. Then security, Security talks about access control, delegations, um, and modular composition talks about like if it's sequential or is it like parallel, or it also sometimes talks about the iteration of the packet. Then flow matching is like it is a basic thing. It talks about the if a packet uh, like as we saw the example, like if there is if a packet consists of a header with the destination address, and in the switches it consists of the flow tables. So with those flow tables, the if there is the if the address matches, then that will help the packet to traverse through that particular switch. So that is what is flow matching. And when we talk about virtualization, virtualization talks about the topology, the packet model, the slicing of the model, the slicing of the packet, stacking of the packet, and the virtual switches. Traffic engineering is something like how uh, the the packets traverse through which path or which route, and through what are its time of delivery, and certain other features as well. And when we talk about monitoring, so monitoring is it tells us about what query language it which query language was used. Um, it also talks about its windowed history, and if there is any external interfaces. So so these are the different SDN programming languages. That is the flow-based management language, which talks about static policies, external events, uh, bandwidth limits, path selection. Netril talks about parallel and sequential module composition. Frenetic talks about windowed packet flow history. Procera gives us an idea about windowed event history. So as we spoke about under the extraction, like uh, in monitoring. So, so in monitoring, I believe frenetic gives us an idea about the windowed history. Sorry, Procera, my bad, sorry. And then Flog. So Flog is it is a event-driven programming paradigm. Netcore is a proactive rule installation, which also talks about network slicing. Then Netcore, Frenetic OCaml is the consistent update. It talks about the consistent updates that are needed. Then Fat Tire, Pyretic. It talks about imperative programming, abstract packet model, topology virtualization. Flowlog talks about finite state language. Um, Fat Tire is fault tolerance to support link failure. Then Netcat uses cleave algebra with tests. Then Merlin is the abstractions to program end hosts and middle boxes. Ponderflow is it specify the language to provide access control. NOF it raises the abstraction level. Kinetic gives us a generic finite state machines um, for located packet equivalence class. So these are some of the programming languages that are used in various fields of networking. Uh, so under SDN programming languages, uh, there are certain open issues and future scope that are related to the programming language. So the first one, that is the programmable forwarding node. For example, if there is a if the switches support programmable forwarding modes, so it requires new routing techniques, and so that can be deployed to take advantage of topology benefits. So the programmer, like, he might need to decide how to insert the code and what bits to enter into the packets and how to process them. Then in libraries, these languages can be extended by simply importing modules available in their repositories. So the current SDN programming language that gives that constructs to deal with specific problems, and so the languages still do not provide an open interface. So that's why these are some of the issues. And so there are, like, in the future days, like, um, there are certain researches that takes place under these particular um, fields. Under network orchestration, researchers may be interested to use language constructs to scale up the resources in an elastic way. So, for example, by setting the routing for some flows to be mapped into multi-disjoint paths, yeah, and or dynamically enabling a spare device. Okay, sorry. Network function virtualization, um, like that gives us how to, implement virtual network functions such as firewalls, network addresses translation, intrusion detection, gateways, or caching on top of commodity servers. So it is an open issue that is introducing a high level language, and it still needs to be constructed to manage the virtualized functions. When we talk about network forensics, it provides means to collect information on network devices for the purpose of discovering evidence of crimes. And this is, detecting a crime itself is a very hard task. So in networking, uh, finding out like uh, that particular field is like um, a very hard task. So that is like, maybe in the future days they might come up with certain um, strategies to overcome this issue. Then application requirements, like um, the applications have known traffic pattern and may be characterized by, like, bandwidth, delay, jitters, and packet loss. So these patterns are difficult to be discovered due to several aspects such as application behavior, time scale, and so on. And OpenFlow updates. OpenFlow protocol introduces new updates according to the user requirements. So yeah, so there is, like, scope for new features in the future. So I would like to conclude that SDN applications were implemented to show the advantages of using the different programming languages, and whatever the programming languages that we surveyed consisted of various features that are applicable in various network fields, and also it is motivated to observe the main feature in order to propose a taxonomy. And also there is more room for research that will be essential in helping us discover more facts surrounding the SDN programming language. Yeah, so thank you, Professor.